Benchmarks are stupid, but at the same time, benchmarks can be fun. Hello, everyone. Today we're gonna dive into the parts of algorithm that I really like, and it's really cool to actually explore, which is the mathematics of it. So, uh, last week I stumbled upon a benchmark, a person doing a benchmark for programming languages, and this guy called Ben Dickens, he actually created this 1 billion nested loop iterations, and he actually tried to see like which one would be faster. And of course, this representation he later expanded. So that he expanded he expanded this later to this one. So actually, he could then use small programming language and he do these interactions, and then he tried to figure out which one has better metrics. And this is some sort of benchmark. And the benchmark is not something that we haven't seen in the world of programming language at all, because you have, for example, the web framework benchmarks, which is one of the most well regarded kind of like benchmarks that we see nowadays, which use libraries to see like how well they good or how well they're good as a performance for web development. So it's more like for a web server development. And see here, there's a lot of like the programming language that are these libraries they are developed on top. And because of these benchmarks, for example, that Rust become very popular. Is this one of the reasons that Rust become very popular, because you always have some Rust library on the top of this framework of web development. Aptix was there for a long time, but not nowadays. But it's fine, like it's still there on the top in 20. And you see that is JavaScript as well. So just JS is something that's been there for a long time as well, which is something that I really wanted to test it out. It's very pure JavaScript development. But then, yeah, so benchmark is something that we have seen a lot, and I wanted to try out something different. So I saw this tweet for this person, and he using this framework called processing, where he could use this algorithm to generate this nice looking cloud or a spiral with each of these points being a number generated from 0 to 999,999,999. And yeah, so I made that. So I made this guy here. So like I made the same. Instead of using this processing framework, I'm using 4 different programming languages. So let's deep dive into this programming language, and then we can go back later to explain about the algorithm itself. So I created here then 4 programming languages. So four, no, five. 1, 2, 3, 4, 5. I work with 5 of them. So I work with Rust, Python, Node, Go, and C. And the idea to generate this spiral was to use what we call it sieve of Eratosthenes. So like this is actually the algorithm. So in mathematics, sieve or Eratosthenes is ancient algorithm for find prime numbers. So this is actually the algorithm we're using, and it's pure mathematical equation that we can get the primitives. And what we're gonna do after that is actually to generate the points and create this in a spiral manner. So that's the high level overview. So you can create the sequence of these prime numbers. We plot it in a spiral pattern, and then the spiral itself, we're going to use polar coordinations, and the animation is going to be rendered real time. So how we're going to do it? It's very simple. So let's go back here to the terminal, and I can explain really simple. This is like in C, but I apply this in every single one. So you can see here that the calculation is basically the same. So like it's basically the same sort of calculation. Okay, so on we have some initialization here on C which is using this library LSDL to actually render the application itself. So this is more like a initiation, creating the window, this yada yada yada. That's something that we don't need to know a lot about it now. I'm gonna link the GitHub repository on the description after this, but after I post the video. And so what matters here is actually this part here. So this part is Sieve of Eratosthenes. So Um, sorry, actually, yeah, yeah. This part is the first part actually of this thing. So what we're doing here is like you get you get an array, all right, and you mark the prime numbers. So that's why I start with 2, and then we're gonna mark the we're gonna assume that every number into that array for an I is actually a prime number. That's how we're gonna do until the number 99999, so almost 100,000. And oh, I forgot I fully here. Okay, so you back here. Sorry. And then so we assume that all numbers are prime until n, and then you get the array the array p is a boolean, and we're going to be marking whether each number is prime. So that's what we're going to do. So like so for every I plus 2 until n, we're marking this as a non-prime, so it's false. So what we're doing here as we for every I, we're gonna mark j as false, and this is gonna create gonna define us as get the prime numbers, and that's what we're gonna do. So like for example, we do everything as true, and then you're gonna have true and false when we're doing pi I, and j is I plus 2. So every time we have like we get the prime numbers from the number 2, and we find all the prime numbers and put this in an array and have true and false into this array. So and when we work on this, so it is here. So while we're running, so running we initiate here, and then while run is true, then you're gonna do a frame count. So the frame count is to limit the amount of frames you're gonna be rendering. So it's gonna be rendering 20,000 frames, and for each frames now you're gonna get like how long the frame is gonna render, so like how long the frame is gonna stay rendered. So what the time it costs to render that frame. So because the spiral is going to be moving, so each movement of the spiral is a frame. And here we just like rendering, drawing, yada yada yada. And this part here is where we calculate the position of the points. So every time we render, we calculate the points, and the points is calculated like this. So this is the x, this is the x, the y, the x we get the sin, and then we calculate the width and the height of the to limit the width of the height of that window, and we position all the points into that spiral, and then after that we just select okay, we draw this amount of points here, and this we render the draw, and you do a render draw points. Okay, so then we end the time, and then you see like how long it took to render this, and we log this into the metrics. So what you're gonna have here, so you're gonna see frame time and points drawn, how many milliseconds it took for that. Okay, that's how we rendering, and that's how we do the calculation, and that's how we can run these metrics. So to show you guys how it does, so let's go to see here, and then I'm gonna run spiral, and you're gonna see here that's fun. It's beautiful, isn't it? It's nice to see like how a algorithm can generate a beautiful thing like that. I really like it, and that's why I enjoy doing it. And so this is going to be logging the metrics, and for each programming language I did that. So like for each programming language I log the metrics. I still think that this metrics here is not quite accurate for C, but I don't know much to say that, but probably could be a problem with library that we have some like long rendering and other stuff. But this doesn't matter at the moment, because what I did now, I collected metrics from all the files, and I create now a average frame time and average point draws for all of it, for each programming language, and I do a plot for them, and then I generate this animation. So this animation here shows a line to 10,000 frames. So this is kind of like how long it took to go to the 10,000 line and then come back. So this is actually the average time to conclude the line. So this is like how it does. So like that's what the speed of the frames, like how long it took for the frame to render all the frames into the how long it took to render all the frames from 20,000 frames. That's the metrics. So the ball faster it goes, it's faster it could render. And no, you see, Node here is winning from C. So that's something that actually a difficulty, because if you rerun Go, if you run C, Go, and Rust, they're all gonna run into the window in my computer. But if you go to Node.js, so let's see. So if you go here, Node, I'm gonna try to run here for you guys. It renders on the web browser. I really wanted to render this as well in the window, but I'm not sure how to do it at the moment. Because this will involve to actually use another framework, and I don't know which framework would be the best. I know that is like, for example, what's the name again? That is Tauri, which is a framework built with Rust, but it's the other one's called Electron. I might try use Electron to do that, because then I think you can have a fair comparison. Because we can see, if you go here to Go, for example, if you go to Go, if you run Go here, sorry, if you run Go, you see here that Go actually, where's the Go? Okay. So see, it renders in a window as well. So it depends on the library. So for example, Go, I use this library here called Abitten, for example, which helped me to create this to run this project. If you go to Python, it's the same thing. So yeah, so Python is the same thing. Open a window as well, and Python is a different library. I use this Pygame to render that. So I believe that I'm gonna need to actually use a framework to run Node.js to have more fair counter metrics. So that's all I learned from doing that. I think it was really nice to do it, and nice to know that we can do, see where the starting is, and actually create a spiral of points, and actually do a really nice project. I'm gonna link this on the description down below. You can have it. And what's your thoughts about this project? Do you like it? Do you have any better idea on how to create metrics for it? Or do you have a better library to run for each programming language? The repository is free, and you can do pull requests. You can open issues as well there if you have problems with running in each different programming language. Of course, this is a very basic. You're not gonna learn programming language for this. It was a very basic project, but then I like it. It was really cool to do it, and I hope you guys like it as well. So that's it for today, and thank you very much. And yeah, see you next.